And thank you, everyone, for being here. I really appreciate you taking an interest in this topic. It's an area that I'm very passionate about. Just to kind of get a read on the audience here, how many folks, when I talk about mixed methods, we're talking about sort of bringing qualitative and quantitative methodologies together in sort of one research plan. How many folks kind of engage in that themselves already or engage with that with a few of their teammates? Yeah, quite a few of you. And that's always something that I really appreciate sort of about the UX discipline is that we're really trying to be comprehensive in how we approach our data analyses. So the next question then is how many folks at your organization have a group of data scientists who are starting to take an interest in customer outcomes and you're trying to overlap them? So not quite as many, but a few of you. Keep your hands up for a little bit and then put them down. Keep your hands up if you are satisfied with the connection you have with those data scientists. Otherwise, put your hands down. We lost a lot of hands, but there's a couple there. Okay. So what I'm going to talk about today is this sort of emerging space of data science. I mean, it's been around for a long time, but this notion of data science kind of bringing together a bunch of disparate disciplines is very reminiscent of sort of what we've seen in the UX space as well. And so I'll talk a little bit about that. For those of you who don't partner with data scientists today, that time is coming. We'll talk a little bit about that soon. For those of you who do, but you're not very satisfied about how we're connecting with those data scientists, that's going to be the point of this talk. How can we collaborate more effectively and have better outcomes when we collaborate with our data scientists? And then for those two of you who say, yeah, you know, I'm pretty happy with how we're collaborating with data scientists, I would urge you to share those experiences, because this is a very new space. And so this is going to be my point of view about how we can make this productive. But we need lots of voices. And on both the UX and the data science side, I find that at sort of both conference circuits, you see one here or there, people kind of talking about this space, and I want to see that kind of grow because it's going to be increasingly important over the next few years. Anyway, let me tell you a little bit about myself. My name's Sam. I'm a UX data scientist at Microsoft. I work on Microsoft Cloud. And to give a little bit of background, this title, UX data scientist, is actually something that's relatively new for me. My background is primarily as a UX researcher. And in fact, I kind of associate most strongly with being a qualitative user researcher. That's when I'm honest with myself, that's where I get sort of the most enjoyment and satisfaction. But late 2013, we started seeing a lot of new programs in data science starting to emerge. And that kind of caught my eye. And I thought, you know, is this something that I should pay more attention to as part of trying to understand the comprehensive sort of point of view of the customer? And so I picked up one of those. I'll mention it briefly. It's the Berkeley MIDS program. That nice thing about that program is that it's run out of their iSchool, which also produces a lot of great UX professionals. So they're bringing this sort of joint point of view together in how they're training data scientists, which I really appreciated. And so that kind of got me thinking a little bit about, you know, how am I going to combine these two together? And that's what led to this sort of hybrid title of UX data scientist. To be clear, I'm not saying that I'm not interested in qualitative research anymore, or that I don't think it's as fun, or that data science is somehow better. I just think that there's a really strong need for this hybrid role to sort of define the future. And so that's really what I'm focused on. Now, Wednesday, we had a great panel about the past, present, future of UX. And Susan had a really great point during that about, you know, UX is sort of has a lot of hype around it right now. And we need to make sure that, you know, we are representing sort of the best of that discipline so that we aren't letting people who maybe don't have the same professional rigor represent that discipline. It was a great point, and I agree with it. But when it comes to the amount of hype, I think data science has UX a little bit beat. This is the Gartner hype cycle for emerging technologies. If you're not familiar with it, the basic idea is that as a technology emerges, there's a lot of buzz around it and a lot of hype. And the expectations sort of quickly exceed what's actually possible with the technology. And after a little bit of time like that, we basically go into what they call this trough of disillusionment, where it's like, that's not what was promised to me at all. I was going to cure cancer, save the world, do all these great things, and now I'm completely let down by it. And that's sort of the opportunity for this technology to sort of start gradually increasing the expectations in line with what's actually possible. Now, the interesting thing about data science is that in 2014, it was kind of on either end of that peak, data science and big data. There's a lot of hype around it, and that's also the time they started seeing a lot of these data science curriculums start to emerge. In 2015, the story is a little bit different, and in my opinion, got a little bit more concerning. You don't see data science and big data anymore, but you see machine learning, which is kind of in that same family of data science. The things that really catch my interest, though, are advanced analytics with self-service delivery and citizen data science. So what does that mean? Basically, the idea there is it doesn't matter what your background is. You don't need a data science background or a statistics background. You too can make an effective use of a data science model. And the idea that hype is driving folks to say, yeah, let me just grab that model and apply it and it'll be great. It's a little disconcerting because there's a lot of, and by the way, my last job was UX research for these tools. And one of the main things that we found is that, it's all well and good to say that we're going to democratize machine learning, but the people who we're trying to reach with those products don't necessarily understand the assumptions inherent in what they're actually doing. And so there's a huge education need that needs to go along with that. So there's a lot of hype around data science. That's the point that I'm making there. On a whim, earlier this week, I decided to look at the educational perspective too. I didn't think it would end up this way, but it turns out that it did. Narrowing just to this field of data science, which again is sort of this emerging composite field, I found that about 84 graduate degree programs exist today, and it just surpasses the number of degree programs in UX. And by UX, I'm including interaction design, usability, data science, HEDE here in UW, et cetera. And that's interesting. 2 years ago, as someone who was looking for these degree programs, that wasn't the case. I'd imagine that it would be probably about half that many. But there's been a really explosive growth. Now, there's an interesting dynamic when we start seeing all of these emerging programs is that the promise that lures you in is that there's a lot of data out there. And if I know how to tap into that data, I can answer any question. Now, of course, the answer is more nuanced. We all know this in the room. And that nuance comes up in a course or in a particular session of a course. And hopefully that person's paying attention so that they really absorb that and take all that meaning in. If not, it can lead to some sort of interesting dynamics, right? Sometimes the other thing to consider is that that these folks are going to be emerging onto the scene, and they might not necessarily know the role that we play when it comes to sort of knowing and understanding our customers. So what do we do about this? What I typically do is I look to some of the respected minds in the field, and it's probably not surprising that IDEO has already blazed a trail for us. This is a great article, by the way, appropriately named Design Thinking in Data Science. It's exactly this intersection space. And the great thing about this is that what happened is the Chicago branch of IDEO decided that they were going to take on 2 joint projects with Datascope Analytics, which is a Chicago data science firm. And they're going to try and see how can we combine sort of the best of what we do to arrive at some better outcomes. And I'll leave the specifics for you to take a look at. But the bottom line for this is that IDEO's message in pretty much every video that IDEO has is consistent here. For the best design thinking outcomes, we need to widen the circle of who is participating in that design thinking. And so they just stayed true to that mantra. They said, we need to just widen the circle to include data scientists and see what things are different. So my message today is that we need to make collaboration with data scientists a priority. And it's going to start with a conversation. And regardless of if you're the person in the audience who's saying that, yes, I'm working with data scientists and we kind of have that friction, or we're not working with data scientists now, it's coming. So this is the type of thing to start thinking about as much as we can. So a colleague of mine, I was talking about this talk yesterday, and she said, yeah, Sam, that's all well and good, but sometimes I literally feel like we speak different languages. And I'm with you. I get that. So I'm going to give you 3 tips about how we can better make that connection. And the first one is talking about staking your claim. Remember my note that data scientists are coming in here, and they may not have that strong understanding of what we do. It could be a little bit more pessimistic than that, actually. In more than a few cases, they might end up coming in with somewhat of a negative impression of what we can do. I don't think they purposefully mean to be antagonistic, but a lot of discussions around some of the work that we do. I lost the presentation. I'll work on getting that back while we, I'll just keep going in the meantime while we fix that. The basic idea is that what they tend to refer to this work as is they'll reference this in terms of small data or anecdotal data. Or sometimes they'll reference some of the work that we do as not even being data. Well, I had a conversation with someone, and I told them about some of the work that I'm doing as sort of this intersection field of UX data scientists. And I say, oh, that's great. I mean, I love working with user researchers, but at the same time, I'm excited that someone in the UX space is actually going to start. I'll fix it. Is actually going to start working with the real data. And I said, hang on a second. Qualitative data is real data as well, actually. So I think we're kind of getting there. It's all right. So basically what I'm going to talk about, I know this is an area that we sort of rehash a lot, and the visuals kind of help, but I can kind of go to it without it anyway. I'm not going to rehash the whole debate about like, oh, how many people do we talk to, and does this need to be a quantitative thing? UXPA has a long history of having those discussions, and I don't think that I'm necessarily going to be able to go in a different direction. What I want to offer you today is instead a point of view around how do we think about that from the data science perspective? Because for better or for worse, we have a long history of having to sort of sell our services, so to speak, and prove our value to the people around us. And that's going to be true again as we continue to partner with data scientists, and we just need to get a little bit of practice on that. So the first one, that's fine, we'll ad lib without slides for just a second. So the common one that we tend to come up with is how many people do we need to talk to? And there's a lot of research written about what's interesting about this discussion for, around how many people do we need to talk to. Sometimes there's a lot of effort put into having a quantitative basis for how many people we talk to. And what's interesting about these formulas, I have some links for references to, of course, Nielsen has a good article about this. Jeff Sorrow has a really good deep dive in terms of the statistical ideas behind this. But the issue that I have with this kind of discussion when we're having a conversation with data scientists, it gets to the quantitative notion of, am I going to get good coverage of the errors that are out there for me to find? It doesn't get to how prevalent will those errors be to our users' population. And at least in my end, the latter is the one that I get asked a lot, right? Like, how big of an issue is this really? And so I still use all of this great reference in terms of making my own decision. How many people do I want to talk to for this particular study? But this isn't necessarily what I lead with when I'm talking to data scientists. There's a few other things that I think are a little bit more interesting. One is this notion of an existence proof. I'm shamelessly stealing this from Judd Anton, who used to be at Facebook, now at Airbnb. And this is the point that he makes to kind of talk about how we can have this better partnership between data scientists and user researchers. And what I like about this, it speaks inherently to sort of the data scientist way of thinking. The idea that, oh, there's an existence proof and we can see how prevalent it is later. It kind of diffuses a little bit of that tension. It's not as tied to numbers because existence happens with n equals 1. So I don't need to start arguing about like, oh, well, is 2 okay, but 3 is not? I can just focus on the 1. And it allows you to do a quick pivot, because once you say that you have an existence proof, your next question is, well, why? And that's where we shine. So giving yourself an opportunity to do sort of what you do best is sort of the excitement there. Another area, we heard about this during our Wednesday keynote from Jen, is grounded theory, this notion of inductive versus deductive reasoning. I like this diagram because it kind of gets at the basis of what this is, if you're not familiar with it. But it's basically this cycling between, I have a theory on what's happening based on the data that's out there or based on my current understanding. That's going to drive then the data that I collect the next time to then further elaborate on this theory and continue to cycle. So by combining those two, you kind of have this way of building up. And what's interesting about building up like that is that it sort of sets you apart as doing something a little bit different from sort of the data science methodology. So that's a way that I found to be pretty effective. One way that I apply this in sort of a very specific way is kind of turning the tables a little bit. Stop asking questions about like, okay, well, how many people are actually doing this? Instead, embracing the fact that there's a lot of variety. Saying that, well, we're designing under this notion that, humans are going to behave in a uniform way, and sometimes they just won't. And part of what we're learning from this qualitative data is that there is this variety, and how do we adapt the design to that? All these issues and more, I kind of generally couch this as constructivism versus determinism. This idea of constructing the model versus determining what's already there are covered in this great text by Cresswell. It's a little bit denser than some of the other things that I'm citing throughout this, but it's definitely a read that I recommend considering as you kind of think about this conversation that you have with data scientists and sort of representing what you're actually bringing to the table. So this is my story. This is kind of some of the tips that I recommend to use, but your story may be completely different. That's not necessarily the point here. The point is that discussing evaluation criteria for, discussing evaluation criteria for qualitative research needs to be something that's really second nature for how we connect with the data science colleagues that we work with. I think a lot of times we get into this habit where someone asks, well, how many people did you talk to? And it's like, oh gosh, I need to explain this again, really? And instead, I recommend being very proactive and just using it as a continuous education opportunity. This is an example of a slide that I have in front of every presentation that I do. If I'm not doing a presentation for results, I talk about it some other time. I considered it a big win when I was having a conversation and bringing up this sort of balance between qualitative and quantitative with my manager. And she said with a kind of a slight annoyance in her voice, I'm like, yes, Sam, I think we all understand now the difference between qualitative and quantitative research. So that told me that I was successful because I had annoyed her so much that she got it. But that didn't actually stop me from continuing to do that. And the reason behind that is that yes, I sound like a broken record, and yes, I might come off as annoying sometimes, but I don't have to answer questions about like, well, did you really talk to enough people for us to know this? Because I spend time framing the discussion before we actually dive into the discussion. The other thing that I'd recommend is thinking about this notion of what is your mic drop moment? And by this I mean, when we think about the issues that we have in qualitative research, there's some sort of data presence that we're going to put behind the issues that we're saying. That's sort of like, here's what I recommend to you, and here's the reason behind it. The full force of data based on the research that I've done to explain to you why I think that this is really important. And it's important to make sure that these mic drop moments, as I call them, are something that is justified by the type of data or the type of analysis that you're doing. Early on in my career, I'm not ashamed to admit, and I see this with some new folks as well, that we do some qualitative research and we'll report something that this is an issue because 80% of my participants ran into it. Well, that gets a little problematic, right? Because my first question is always going to be 80% of what? How many people did you talk to? We're begging the question we don't want to answer with that. So focusing more on the mic drop moments being about the why and really sort of sitting in that space is going to help with a little bit of that success. So that kind of gives you a little bit of idea about just staking your claim. And I just want to reinforce, this won't necessarily be an easy conversation. We're dealing with data scientists who might just have this idea that I'm going to go solve all the world's problems and answer all of the questions from data without needing any assistance from anybody else. So it might be take a little bit of time. But I think that it's really important because the more people who start having these conversations, we're going to keep chipping away at this issue, which is going to be beneficial for the entire community. So, and I know I'm not presenting this. I'll just kind of hold that in there. So on to tip number 2, which is speaking the language. So we've kind of talked a little bit about how we can reinforce how we can reinforce some of the work that we do, but we need to kind of go on the other side too and say, what is the language that they're speaking, and let's have enough knowledge so that we can actually jump in and work with that stuff. So as an example, I want to tell a brief story here. And this is basically a while back when I was working on developer tools. And we had this big meeting where we had personas at the time, just to be clear. We had an idea of segmentation. But someone came along and said, we've done this really interesting algorithm. We've got a great cluster of folks. And these are just really, they're meaningful clusters. They're the ones that we absolutely need to look at. And I think that if we just focus on these, it'll be really great. So yeah, they didn't really line up with our personas, and we're kind of saying like, well, maybe this one is kind of like this persona, but we don't really know. But we still had this sort of top-down message that like, yeah, this looks like really good research, so everyone should sort of snap to it. So on the other end, I went to the lab and still recruited the same way that I always did, but I was also asking the questions about, the questions that would determine those segments that we were talking about. And over 2.5 years of running those types of studies, I never found any correlation between the segments that I was recruiting and the segments that had sort of been found by this other analysis. And I never found a distinct difference in terms of how people were actually using the product based on those segmentations. So what's going on here is that did someone do something wrong? Is one of the analyses wrong? Am I doing something wrong? And so to kind of get to that, I want to kind of break down some of the terminology in terms of that data scientists might be using with some of the models that they do. And this one, there is a little bit of stuff, so I think I do need to, yeah, no worries. Okay. So we'll do the best that we can. So there's basically, this slide will be up there in a little bit, so don't worry too much about it. So there's different types of models, and so as this slide builds out, the thing that I'm going to say is that this is combining a couple of different data science courses into one. So this isn't going to be the most complete model. You're not going to be ready to go with sort of running your own data science analyses necessarily after this. But I want to try and give a little bit of a framework that you can build off of. And so one area that I think we might be comfortable with, especially if we're dealing in the quantitative space, is the notion of a descriptive model dealing with descriptive statistics. This is something that data scientists are taking from the field of the sciences, so psychology especially is also sort of using some of these same ideas. And what they're basically working with are a couple of different key aspects, which are statistical significance, basically the probability of obtaining the result given that a particular hypothesis is true, and practical significance, which means, yeah, it's likely to be a real thing, but is it important enough, right? Like if I say, hey, you can stand upside down on your head and lose weight if you do that for 30 minutes each day, if I tell you that the amount of weight that you would only lose is only 0.1 pound per month, you're probably not going to be that interested in doing that because it's just not practically significant. I want to spend a little bit of time on this notion of statistical significance because there's actually an interesting thing that happened a few months ago where the American Statistical Association came out with this interesting article. And I do recommend this. I know I mentioned, hey, no statistics background needed for this talk. And now I'm saying, go read about p-values. But really, this one is really approachable. And there's a couple of things that I think that this audience would really like about it. First of all, this particular paper, the first half of it is entirely retrospective about how crazy it was to get a group of statisticians to agree on something very fundamental. And my favorite quote from that sort of early introduction is this one. The statement process was lengthier and more controversial than expected. And that's probably the least emotional way I've ever seen a statement worded about something being very sort of emotionally charged and difficult to work with. So it's an interesting read, and I think it's something kind of worth going into. The truth behind that statement is basically that it took over a year for this group of statisticians to kind of agree on what they could reasonably say about statistical significance. Now, the second half of this is also really interesting. We'll come back to why that matters, that it was sort of difficult for them to lock onto. But what they were able to come up with are 6 principles for p-values that are meant to be very approachable, that everyone can consume, not just the data scientists, not just the statisticians, but they're approachable for folks. And what they did is they started with this first one, which basically says, here's what a p-value can say. And then the rest of them, they tried to tackle some of the primary issues that are plaguing the sciences today. So a couple points that I want to make out about here. First of all, check out principle number 6. By itself, a p-value does not promote a good measure of evidence regarding a model or hypothesis. What this is basically saying is that if you see a data scientist who's representing a p-value only as their mic drop moment, that's an opportunity for discussion. To say, it's great that that p-value is whatever state it's at, but let's talk a little bit more about the context behind what's actually happening here. And secondly, we can tie a couple of thoughts together. Remember what I said up front about this notion of citizen data science, where people who don't necessarily have the background are going to start engaging in this a lot more. The need for this statement came from when the professionals were already misusing some of this stuff. So now we're going to let in a bunch of other folks who may not necessarily have that background. The opportunity for this is going to get, for misinterpretation is going to potentially grow as a result. And that's something that we need to be aware of. And if I combine that notion with the fact that it took some of the brightest statistical minds a year to sort of agree on this sort of fundamental statement, what I come down to is that the reason for this is that statistics are kind of hard. Every statistics course you take starts with a little unit at the beginning saying that, look, our brains aren't really good at thinking probabilistically and statistically. It's just not how we're wired to think. This stuff is hard. It is hard for the experts. So number 4, principle number 4 in particular is one that resonates with me because this isn't just about what's being reported, it's also a culture change. We need to be able to have a culture of transparency and open discussion around around the results that we're having. And so I encourage that sort of open discussion as well. Talk about a couple other models and sort of key aspects. One that gets a little bit more into the machine learning space. It's called typically a predictive model. And this is a little bit different. It's not so much about describing the world that's out there, but as more data comes in, I want to be able to predict something about that particular data case. And the accuracy with which I do that is kind of a way that you can think about that. I won't go into these in as much depth as I did with the descriptive models, but I do want to just give an example to kind of bring that home with a Microsoft bot that was recently released. The idea is that you can train this bot on a number of images that are out there, and it starts getting really good at identifying what's actually out there. So for example, I think that's a man and a dog on a rocky beach. But it's not necessarily a sure thing. If I do a call back to the big internet meme of 2015, it says about that, I'm not really confident, but I think that's a close-up of a suitcase. Which is fine. I mean, the thing behind these is that you're training a model to be able to identify some of these things, and sometimes it's going to be wrong. And you can see in the way that the bot is wording things that it kind of gets at that notion of, I'm not necessarily confident, but this is my prediction with what that's going to be. The last one is called, it's fine, a representation model, or it's part of unsupervised learning, and that's what we saw with the other one. And this, it's not quite as cut and dried in terms of what we're actually looking at, but there's some sort of optimization criteria that you're using to be able to say, am I doing good enough given the data that I'm actually working with? So what's interesting about that is the only one that isn't sort of just a true calculation straight up. It's actually causing you to sort of step back and think a little bit about, what's the basis? What is the question that I'm actually trying to get at with and answer here? And let's understand the context a little bit more. So if I go back to this question about, between the big segmentation that we had to kind of forced upon us in the development space versus the personas and the work that I was doing with usability testing on the other side, which one of those is necessarily, was it a case that there was something wrong? No, not necessarily. On the segmentation side, what was basically happening was that they were really good segmentations for the data that they had. And if they don't have data that's taking into account some of the outcomes that I care about on the UX side, that drives some of the usage behaviors, then we're going to start running into some issues. The basic idea here is that none of these measures were actually getting at the contextual meaning behind the model. So, what does that actually mean? So partially, this is a long way around to say that, one of the things that we excel at is the why of what's actually happening. But another thing is that we just, kind of like I was saying with the example that I was talking about before, we need to be aware of the context of the data. There's a lot of research emerging, being written right now about how even with all the data that's available, if you're building a machine learning model, there's a lot of opportunity for it to still have some bias in there. And the source of that bias is that the person building the model may not be thinking about what data is really necessary to be fully explanatory about the condition that I'm trying to go after. The model is doing the best it can based off of the data that it has, but if you're giving it an incomplete story to begin with, it's not necessarily going to be a complete story in the long run. So how can we couch this a little bit more clearly? One thing is, okay, sorry. It's actually a really good visual model of a way of thinking about some of the way that we think about some of this data. And for those of you who, all right, it looks like we're kind of getting back. For those of you who are familiar with the notion of product management, there's a lot of discussion around sort of what makes a good product manager. And there's this interesting Venn diagram that's sort of the collection between the user experience, the technology, and the business. And I've always really liked this because I think that it really gets to, yes, what a product manager does, but I think it also sort of speaks to a lot of the considerations that we also put into play when we're thinking about some of the research that we do and the results that we have. So what I like to think about is taking this and using it as a way to think about the data that I'm actually working with and thinking in terms of attributes. So in terms of tech attributes, that's basically the type of stuff where if I have a bug that's happening in my system, I need to be able to troubleshoot that bug. Well, what's actually going on? Is it that you're on a particular operating system? Is it that you're on a particular browser? That's interesting to know if we're trying to troubleshoot those problems. But at the end of the day, there are some things that might drive how people are actually using your product. But in a web page, for the most part, you won't necessarily unless there's something completely broken, you won't see a lot of difference in how people are interacting with your product. Business attributes are those ones that are driving whether or not someone is making a business decision to pay you money, to have some sort of successful business outcome that they expect. And an experience attribute then is one that's sort of predicting or driving how people are actually going to use the product. And sometimes these attributes can overlap, but my claim is that we need to spend a little bit of time thinking about these UX attributes, and further, that the user research that we do can uniquely provide a lot of great insight into what those experience attributes can be. So let me just give you a few examples of what we're talking about here. So let's go back to the developer tools. This is something that I've talked about a little bit. On the technology side, our developers were always interested in what programming language are you using, because they had to understand the compiler, and if the compiler was breaking, that's important information that they need to have. Now, the programming language that you're using, there are some things that you'll develop a little bit differently, but that's not necessarily something that we're going to think of as sort of a key attribute in terms of how people use the product. On the business side, I might look at things like who the project audience is. So my users are developers. Who are the developers' users? And the type of app that they're building. Now, the interesting thing about this is that that model that I was showing you earlier, that cluster analysis, was really good at clustering the developers based on this type of data. And it was really interesting in terms of how we might go market the product. But the shortcoming that I was running into is that it wasn't necessarily good at describing how people would actually interact with the product once they had it. Within those segments, there was a lot of variability in terms of how they were using the product. So what matters from the experience point of view in this case? As with a lot of professional tools, educational background is a big one. Whether or not someone has a computer science degree fundamentally changes kind of how they think about writing their programs. Keyboard proclivity is another big one that I ran into, where sometimes people would be completely keyboard driven and they'd always want to know all the keyboard shortcuts. How they use the product fundamentally changed if you were really into using the keyboard and all the keyboard shortcuts versus if you were more mouse driven. And then just the project complexity, that's one that I put on there to show that there's a little bit of an overlap. Project complexity matters in terms of performance on the technology side, but if you have 100 different code files, you're going to have all these tabs open. You're going to have to be like struggling with managing all of those tabs. So that's also something that can impact a little bit the experience side of the equation. Another example is freemium games. And in my case, I will admit that I spent a little bit, way too much time on this simple game called Criminal Case. And the idea behind freemium games here is that you don't necessarily have to pay anything to download it, but you do need to pay a little bit of money if you actually want to maybe make the game go faster or do better things inside of the game. So what are the technical attributes? Well, the platform that you're using, am I going to be using this on an iPhone or an Android? That would be helpful for a development team to troubleshoot. Whether or not it's Facebook connected is another one of those things that I'm probably interested in tracking. For those of you who are familiar with gaming, you might be familiar with this concept known as whales. Data scientist friends of mine who work on these freemium games are really interested in this. The basic idea is that the definition of a whale is someone who's spending, upwards of thousands of dollars per month on one of these games. And it seems crazy, right? Like, how do you spend so much money on one of those? And some people do for various reasons, and it's because they're really invested in the game. And obviously, from a business perspective, you want to cultivate that as much as you can. But the question is, first of all, are all whales going to interact with your game the same? Probably not. And also, do we care about non-whales too? Because they're probably playing the game as well. So from an experience perspective, we might want to consider things like completionist tendencies. That's me. I'm really anal about once I start a game, I want to be able to finish it. So I don't play MMOs because they don't end, and I would never leave. But the other thing is like game session time. Am I doing this just really quickly on the side because I have a minute to kill? Or am I going to spend 30 minutes just kind of playing this game because I want a little bit of downtime? How I interact with the product will be fundamentally different there. A friend of mine went to go work on a fitness band and asked me this kind of question after an earlier iteration of this talk and said, yeah, that's all well and good, Sam, but if I'm going to go work on a fitness band, what do you think? How would you break that down in this case? And so I turned it into a slide. And the idea is that from a technical perspective, the number of devices you might be connected to and the types and versions of those devices might be important or of interest. From a business perspective, frequency of exercise is going to be a big determining factor sometimes, whether or not you want to make the purchase. Also, friends with the same kind of band, like if you have a bunch of friends with Fitbit and you care about that social component, that's going to drive a little bit more of the purchase decision than some of the other variables you might consider. But from an experience perspective, there's a number of things that are a little bit different. Finger shape or fat fingers, kind of true for any sort of small screen experience, is going to have a dramatic impact on how you're actually using the product and potentially some frustration aspects. Farsightedness, if you have to kind of do a lot of this to try and understand what's happening, or if you have skin irritation. So I think the net point across all of this, giving you a few examples, but we are uniquely qualified spending the amount of time we do to understand the why behind what we're observing and how our products are being used. We're uniquely qualified to articulate the experience attributes of our products. What I found is that it's sort of a given on the other two sides of the coin. Developers are really interested in collecting the technical attributes because they need to be able to troubleshoot their bugs really quickly. They're really interested in collecting the business metrics because they need to know whether or not they're going to be making any money. But on the experience attributes, no one's pushing that if we don't push that. We need to be able to represent some of those other attributes to be able to have sort of more comprehensive models about how we think about our products being used. So that's a little bit about speaking the language. I'm just going to close by my last tip, which is getting involved. So what I find in general as I go around and talk to different UX teams who are working with data scientists and vice versa, is that if collaboration is happening today, there's a lot of good stuff happening in terms of folks kind of sharing in each other's insights. So I might go attend your report out, you might send me a report that I read. And that interchange is driving a lot of the future research that's actually happening. But what I quickly began to learn is that there's only so much that I can do. Yes, this notion that I have a finding on the qualitative side, and then that's going to drive sort of a quantitative analysis to do some triangulation. You can have that back and forth, and it's really productive. But a lot of times I would listen to that readout and think, oh man, yeah, I know I'm on the qualitative side right now, but if you would only have asked this question or collected this other kind of data, there could be a whole lot more value in terms of what we're actually collaborating on here. And so one thing I'm really focused on, and this is going to be a different story for everybody, is how can we get involved a little bit earlier in the process? A/B testing is one of the common examples, and so that's one that I'll kind of close out with today, some ideas about how you might go about starting a conversation around that. So first, I just want to kind of give an overall metaphor for A/B experiments. I feel like when people talk a lot about it, it's like there's this mountain of sort of optimization that we're going to go climb. And we might not be the most efficient in climbing it, but the point is we want to just take each step gradually going up towards the top so that we're continually optimizing over time. Now, there's sort of an assumption at play here that isn't exactly right because it doesn't really look like this. It looks a little bit more like this. There's not really a clear indication of where you are on that mountain range and which mountain you happen to be climbing at any given time. So I might be over on the complete right side of this image, and yeah, I'm moving my way up, but I don't necessarily know whether or not I'm getting to that peak optimization or whether I'm optimizing myself into a corner. And what tends to happen, and what I hear a lot about with A/B testing is, again, oh, I'll have an A/B testing result, that UI is good or that UI is not good. And then I kick it back to the team, and either the UI was accepted or it wasn't. And if we want to know more about it, OK, great. We're going to go run the qualitative study on the UX side, and we'll try and get a little bit more information. But I'm continuously curious about, is there a way to provide greater context to the A/B test findings so that's not just so much just throwing it over the wall, but instead we're kind of helping each other to advance this shared cause of understanding our users? And the answer to that is something that I know I said no statistical background needed. This is just a minor thing, is heterogeneous treatment effects. Ignore the name. I'll describe a little bit about what that's all about. The basic idea is that if we have A/B test and we find that in our control group our KPI is some value and our treatment group is some sort of significantly better value, we know that we have a really good test. But what we don't know is if, say for example, I'll take an experience attribute about whether or not this person is a novice in using my product or an expert in using my product. There's a couple of different cases. We could say that, yeah, that KPI improved because a few of our novices and a few of our experts equally had gains and kind of are all experiencing the product a little bit differently. But another alternative is that this change that we did was really gangbusters good for experts, but it left novices behind. And that's kind of what we call a heterogeneous treatment effect. And I don't know about you, but that's the kind of thing that if that analysis came back to me, my response to the A/B test would be a lot different on one case than it would be on the other. And What's interesting to me about this, it's another little story time here. When I was taking this course on experimentation and this notion of heterogeneous treatment effects came along, I thought, oh, this is great. This is a notion that I'd had in the back of my mind for a long time, but I just didn't know what it was. And now I know a name for it. I'm going to go look up A/B testing and heterogeneous treatment effects, and there'll be all this research about like how this works and great case studies, and it'll be great. And I went and I looked and I found nothing. And so I went back to the instructor and I said, what's the deal? You told me that you should always, when you're doing an experiment, test for your heterogeneous treatment effects. And I feel like this is a really good application for it, but I'm not seeing people talking about it. Why is that? And he said, well, there's a couple things. When we're dealing with a scale of data that we tend to deal with usage data, the likelihood that a heterogeneous treatment effect will undo your significant effect, basically turn that significant KPI lift into a not significant KPI lift, very, very small. So basically, we're saying that if I see that this is a significant improvement, it's pretty much guaranteed going to happen. So given that, why would I spend the money necessarily to instrument a whole sort of additional analysis on top of the A/B tests if there's not necessarily going to be any guaranteed payback that I'm going to get from that? So that's something that I thought about for a while. I think that from the UX perspective, we can get a lot of value from that. And then a little while later, I was relieved because I saw a great talk called Experiments in Action, which I recommend in general if you're interested in this notion of A/B testing, where the head of data science at Airbnb talked about this entire experiment process, but at the very end said, by the way, one thing that we always do is we check for heterogeneous treatment effects. For example, we might check on the browser that that user was using, and if one of the browsers has sort of a lower effect than the rest of the other browsers we're seeing, that might be a leading indicator that there's a problem that we need to fix that's unique to that browser. Now, referencing back my earlier point, that's a technical attribute, and that's definitely worthwhile to instrument. But we have the capability to say, what are some of these experience attributes that can be really worthwhile to help us get greater context for some of the data science work that we do? So that kind of sums up this notion of, when we start talking about partnership with data scientists, being really clear about the claim and the role that we play, the unique value that we're bringing with our qualitative data, speaking the language that they have so that we can start having these conversations about where some interesting areas of overlap are, and getting deep into some of the specifics about kind of where we can actually improve each other's outcomes earlier on in the process, and then getting involved to actually make that happen. So I encourage you all to go start a conversation with your data scientists. If you have any questions, I would love to take them. While you're thinking about one of those questions, just a couple of quick notes. I know that the surveys are all on the website now, I guess. But I would really welcome any and all feedback about this. This is an area that I'm very passionate about. So I want to continually refine this message and make sure that we're kind of continuing to encourage these good conversations between UX professionals and data scientists. The second thing that I'll say is that if this notion of UX data science is interesting, we're hiring. We have a couple positions that are open, and so I'd love to talk to you about that as well if you're interested in that. Thank you, and if you have any questions, I'd be happy to take those. Oh, thank you. Yeah, please.
I didn't really understand your point about the experts versus novices in the heterogeneous treatment effects. Yes. That seems so hard to identify that you've got a treatment effect. Can you just clarify that a bit more? Or how could you tell?
How could you tell what the...
Yeah, how could you tell
with the actual, that the treatment effect is actually happening? The way that you do that is with the statistical analysis on top of the effect that you're actually getting. So for example, if I'm running some regression that basically says, here's the outcome that I'm looking for, whatever KPI, and its correlation with whatever change that I've made to the UI. You also look at the interaction term between that change to the UI and whatever experience attribute that you're interested in, and look for a statistically significant effect there. So it's on this data science analysis side more so than just sort of an analysis on that.
I'm missing something. The attribute itself, where did it come from?
Oh, the attribute itself, where did it come from? So that's a little bit more on the earlier part of this, when I was talking about defining the experience attributes. So it might not be, some of these necessarily aren't going to be something that are just lying around. So novices and experts, that's something that I think comes from an understanding that we generate over time by doing our qualitative research. So if we start to see that novices tend to have this behavior, or maybe, I work with a lot of professional sort of service tools, so it might be that, how many of these, programming solutions or models are you actually building? That might be an indicator of experts versus novices. So there might be a little bit more a lower level indicator that's easy to capture in some of the usage data that can be a representative for some of these things. It's a process to define some of those attributes sometimes, but
I see. So you've got a data point that's a stand-in for that.
Essentially, okay. Right. And I think that it varies over time. I mean, it's how. My underlying thesis is that it's up to us to define those, and so sometimes it might be a stand-in point, but there's also opportunities, again, for this collaboration to say, let's go back to educational background. That's one that we're never going to get just by people using the product, right? But we can do a survey to get some, it won't be all of our users, but some of our users, and understand what their educational background is, and then use machine learning to start to say, what are some of the other attributes, the usage behaviors that are correlating with the educational outcome that we saw, and then use that to sort of better understand what those experience attributes are. So I think that there are ways, none of these they aren't always going to be direct. Some of them will be, some of them won't, but starting that conversation about what some of these experience attributes are, I think if data scientists and UXers come together, there can be a lot of benefit to that.
Indeed. Thank you.
Thanks. Anything else? If not, it's time for lunch, right? Well, I'll be around, and I'm certainly happy to answer questions, just sort of one-on-one, but otherwise, I really appreciate your time and attention. Thanks very much.